P block, group 17, part 3. Reactivity towards metals. Halogens react with metals to form metal halides. For example, bromine reacts with magnesium to give magnesium bromide, simple example. The ionic character of this halides decreases in the order of MF, MCl, MgBr, Mi. Okay, now ionic character MF is more. So this is one first question, where M is monovalent metal. If a metal exhibits more than one oxidation state, the halides in higher oxidation state will be more covalent than the one in lower oxidation state. This point is very well known to you. SnCl4, PbCl4, SbCl5, UF6 are covalent than SnCl2. Here you see +2 oxidation state. Here it is +4 oxidation state. Remember Fazan's rules. Lower the oxidation state, more ionic. Higher the oxidation state, more covalent. So these are all covalent. These are all ionic. Expected trend. Reactivate towards other halogens. These are called interhalogen compounds. About this we'll discuss in a very special category. These all we are going to discuss soon. Sorry. Fluorine exhibits only -1 oxidation state. Remaining can form +1, +3, +5, +7. The reason you can say because of higher electronegativity, no vacant d orbitals. No vacant d orbitals, so it cannot. Here some questions are there. Dissociation enthalpy. Compare oxidizing power of fluorine and chlorine. Fluorine is very strong than chlorine. Give 2 examples to show the anomalous behavior of fluorine. Not 2. You just go up. You can see many. C is the greatest source of some halogens comment. Exactly. So coming to chlorine. Chlorine part we'll discuss now. In this we'll complete chlorine. Right. Chlorine was discovered in 1774 by Scheele by the action of HCl and MnO2. In 1810, Davy, all this blah blah blah. We don't require this history. Okay, now we respect them, but we don't require that. Preparation. It can be prepared by any of the following methods: MnO2 plus HCl, MnCl2 plus Cl2 plus H2, and NaCl plus MnO2 plus H2SO4, MnCl2 and Cl2 is formed here. KMnO4 when treated with HCl. So KMnO4 is oxidizing HCl to Cl2. MnO2 is oxidizing HCl to Cl2. MnO2 is oxidizing Cl minus to Cl2. So all these are oxidizing reactions. In all these cases, you see Cl minus is present, that Cl minus is converted to Cl2. Okay, statement 1, statement 2, statement 3. But this question is important. Deacon's process, here we are using CuCl2. By oxidation of hydrogen chloride using CuCl2 catalyst. This is very, very important. Last lesson also, in P block also, we were discussing about this oxygen. Oxygen can oxidize HCl to Cl2. Electrolytic process, we can see this in Nelson's process. Okay, now where we are using sodium chloride plus water brine solution. When it is taken, brine solution, you will be getting there NaOH, H2 and Cl2. Very, very important method because all these are important. Chlorine is liberated at anode. So chlorine at anode. Dear NEETians, okay, now NEET appearing students, remember these kind of things. As a byproduct in many chemical industries. Coming to the properties. It's a greenish yellow with pungent and suffocating odor. 2 to 5 times heavier than air. Why? How? Because air means nitrogen oxygen whose molecular mass you can take 29. Cl2 means molecular mass is 71. Okay, now this should be not 2 to 5, it should be 2.5 times. 2.5 times heavier than air. Second mistake in NCERT in this chapter. Okay, now. It can be liquefied easily into greenish yellow liquid which boils at 239 Kelvin. It is soluble in water. See all these reactions, nothing is there to discuss about this. Okay, now this is some special. But no worries, they cannot be asked. It has great affinity for hydrogen. It reacts with compounds containing hydrogen to form HCl. So these reactions little interesting. H2S minus 2, 0, Cl 0, minus 1, Cl2 0, Cl2 0. In all these cases, chlorine is undergoing reduction beta. So others are oxidized. Here you see carbon is with hydrogens. Here only carbons are there. Loss of hydrogens is oxidation. Hydrogen is 0 oxidation state. Here hydrogen is +1. So it's a good affinity for hydrogen. So oxidizes others. With excess ammonia, chlorine gives nitrogen and ammonium chloride, whereas with excess chlorine, nitrogen trichloride explosive is formed. So this is one important one. When ammonia is excess, NH4Cl plus N2. When Cl2 is excess, NCl3, which is explosive. Very, very important reaction. Asked many number of times in exams. With cold and dilute alkalis, chlorine produces a mixture of chloride and hypochlorite, but with hot and concentrated alkalis, it gives chloride and chlorate. These reactions you are discussing in disproportionation since long time, right? You know about the balancing of this. You are balancing of these react. You did lot of work on this. Dilute -1 +1. Concentrated, if you are using, it is dilute -1 +1. Concentrated -1 and +5. Both are disproportionation reaction, where chlorine 0 is converted to -1 +1. Chlorine 0 converted to -1 and +5. With a dry slaked lime, calcium hydroxide, it forms bleaching powder. CaOCl2 bleaching powder. CaOCl2 will be like this, OCl- and Cl-. Whereas one chlorine is in +1 oxidation state, another is in -1. This is also important question you need to remember. The composition of the bleaching powder is CaOCl taken twice, CaCl2, CaOH taken twice, 2H2O. Neat note. Okay. Chlorine reacts with hydrocarbons and gives substitution products with saturated hydrocarbons and addition products with unsaturated. This is free radical substitution reaction. Check our first year notes. It is electrophilic addition reactions. Second year, first year organic chemistry notes. Second year and first year, both years you can see. Chlorine water on standing loses its yellow color due to the formation of HCl and HOCl. Like greenish yellow color we said, na? That greenish yellow color. The ink color what you are using is like that. Hypochlorous acid HOCl is so formed. It gives nascent oxygen, which is responsible for oxidizing and bleaching properties of chlorine. So when chlorine reacts with water, this one, it gives you HCl and HOCl. HOCl will be giving you HCl and nascent oxygen. It oxidizes ferrous to ferric, sulfide, ferrous to ferric, right? Sulfide to sulfate. Chlorine oxidizes sulfur dioxide to sulfur trioxide, iodine to iodate. So all these reactions you see, it is ferrous converted to ferric. It is sulfide converted to sulfate. It is sulfur dioxide converted to sulfuric acid. It is iodine converted to iodate, iodic acid. It's a bleaching agent due to oxidation. Yesterday we were discussing sulfur dioxide. Sulfur dioxide is because of reduction. It is because of oxidation. It is used for bleaching wood pulp required for the manufacture of paper and rayon, bleaching cotton textiles, in the extraction of gold and platinum dyes, drugs, organic compounds such as tan. In sterilizing drinking water and preparation of poisonous gases such as phosgene, tear gas and mustard gas. All these formulas you need to remember. Mustard gas is CH2 with one sulfur, CH2 both sides chlorine. And CCl3NO2 is tear gas. Generally police people use tear gas. Okay, now when people crowd is there, generally they go for security purpose, they go for release of tear gases. Phosgene is also very poisonous. This reaction already we have discussed now. Gives the reason for the bleaching action of chlorine because of oxidation, this reaction. Name 2 poisonous gases which can prepare for chlorine gas. Now why 2? You take 3, COCl2, tear gas and this one. Hydrogen chloride we will discuss in another video. Thank you guys. This is Lakshma Reddy sir.